Hi. Hannah would like section 4.4, problem number 28 worked out. So I went ahead and drew a picture first just to get us started because word problems can take a little while. Um, but remember that he says that ebb and flow took a boat out. They left the dock. Time is the number of minutes since they left the boat dock, okay? How much time has gone by? That's all it is. F of t is the distance the boat is from the boat dock on the way out, which is a little confusing, I think, and g of t is the distance on the way in. So at any given time on the way in. So keep that in mind, and let's just find this g of t and f of t. So remember, f of t equals 32t. Another way to write this, if I'm going to do this on the x and the y axes, I could think of this as y equals 32x. I can see that this is going to be a linear function. It's actually a direct variation. And so we'll go ahead and just make a little chart here, because when we plot this, we're gonna need a chart. So here's x and here's y. Now they asked you to find, I think he asked you to find some different times, like, 3, 7, and 10. So when x, which is time, is 3 minutes, 7 minutes, and 10 minutes. Now, I'd rather you keep this t and f of t, but I know that gets confusing for you. So, but remember, keep in mind, x is really t, and y is really f of t here. Okay. Well, let's see, when t is 3 minutes, 32 times t. I don't know, where's my calculator? Right here. Let's see, 32 times 3, I get 96. So it's going to be about 96 meters, I believe, away, because I believe this is in distance from the boat dock in meters. I believe that you were told that that was in meters. Okay, and so when it's 7, let's see, 32 times 7, I get 224 meters away, which makes sense, it's further away. And after 10 minutes, it's going to be 32 times 10. I suppose I could do that in my head, huh? So it's 320 meters away. All right, so if I'm going to plot that, I mean, it's a line. Let's just go ahead and see if I can get some plot happening here. I don't know. All right, well, y, or f of t, is going to be in meters. Let's plot this up like, let's say like this is 100 meters right here. So coming up, 1, 2, 3, 4, 100 meters. 1, 2, 3, 4, this will be 200 meters right here. Do you see? And then 1, 2, 3, 4, we'll make this 300 meters. It doesn't really matter how you scale your axes, just have to stay consistent. It's like 1, 2, 3, 4, this would be negative 100 meters down over here. Okay, and then our time, we could just count up by ones. Should I just do it by one maybe? I guess so. 1, 2, 3, 4. This would be about 5 minutes right here, right? 5, 6, 7, 8, 9, 10. This would be 10 minutes. 11, 12, 13, 14, 15 minutes would be about right here. All right, but this is all time, and it's in minutes. And it's, I mean, this is really, it's t, or you can think of it as, of course, it's the x-axis, right? But we're going to let the x-axis be time. And then this is distance over here. And we've got, you can think of it as f of t or g of t. Okay, so 3, let's see, 3 minutes maps to 96. So it's going to be right about, I don't know, right about there. We'll just make our point big fat point there, right? And then 7 is going to go up to 224. So almost, oh, I don't know, just a tiny, tiny, tiny bit under this line here. Just right there. Oh yeah, look at that nice line there. Okay, and then 10, let's hope this stays in the line. 10 is going to go up to 320. So 10, 320. I have the hardest time seeing on this. So about right there. Yeah, look at that. Not bad. Not bad at all. Now, if x were 0 at 0 minutes, right, you could just see, well, 32 times 0 would be 0. This is a direct variation, so it is going to go through. It is going to go through. Now, I can't use a ruler with this. It won't work on my little pad there. So, at any rate, that's the best I'm going to be able to get it. But that's not bad. That's not bad. All right, now let's do g of t. Do the same thing here. G of t. All right, I've got t and g of t, right? Or remember, it would be x. This is x, and then g of t would be y. All right. And I think that they had you find some values there. Let's see. We had to find the values of g of t at 18 and 23. We'll find g of 18 and g of 23. That's going to be a problem because that's going to be way over here. That means my scale isn't very good. 15, 16, 17, 18 would be right here, but I can't quite do 23. So that's all right. I'll figure something out. 18 and 23. All right, well, 18, let's see, we're going to take g of 18 is going to be negative 17 times 18 plus 510. And it looks like I get 204. I get 204 meters there. Okay, and then at 23 minutes, I'm going to get negative 17 times 23 plus 510, and that's going to be 119 right here. Let's pick like what's happening at 15 meters. Let's just see right here, okay? Let's take negative 17 times 15 plus 510. I get 255. 255 meters. I mean, I just picked the 15 because I just want to, my scale, for one thing, my scale's not going to go over. So I wanted to pick a couple of points in the area where I can fit it in. Let's see, so when I get to 18, which would be right here, so I really should have done my scale different on the x-axis, but I don't want to redo it. I don't want to redo this. Okay. So we're going to come up to 204 here, come just a little bit past 200, 204, about right there. Just a tiny bit past. Okay, it would be the 18. Let's see, 15 is 255. After 15 minutes is 255, just a little bit past right there. Ooh, look at that. Okay, and let's see, 18, 19, 20, 21, 22, 23. It's off my scale. Yeah, I better not do that. Let me do like, let me look at what's happening at 10. Let's see what's happening here. Let me do that one at 10. Okay, when t is 10, you can see here, let's see, I'm going to get negative 17 times 10 plus 510. Ooh, I get 340. All right, so at 10 minutes, I get 340, which, ooh, 340, so that's about right. What would that be? About halfway, not quite halfway up, about right here, I think. About right there. I don't know. Something like that. And again, I can't use a marker. Okay, I can't use a exact ruler. All right, cool. So that's what it looks like on the graph. Now it says here, calculate the point where the graphs intersect. All right, well, I really have two linear functions here, so where they intersect, I think, is where they're going to be equal, right? Where they're going to be equal. So can I just erase these charts right here? And I've got f of t and g of t. Did I write them down anywhere? Yeah, I did. So I can erase these. All right, so where they're going to be equal, let's do that next. That means g of t is going to equal f of t. So let's see, 32t is going to equal negative 17t plus 510. And let's see, what at what time does that occur? That's going to be the point of intersection, right? So 32 plus 17, 32t plus 17. So 32 plus 17, we get 49. T is going to equal 510. So let's see, it's going to be 510 divided by 49. Yeah, about, at about 10.4 minutes, right? That's about when they're going to meet, just a little bit. And that makes sense, just a little bit past the 10. That is looking like my point of intersection about right there, You can see about 10.4, approximately. They're going to intersect at about 10.4 minutes. Now, when they intersect at 10.4 minutes, I mean, I don't know. I'll just put that into the f function. We'll see how far apart, where they're at, where the boat is. 10.4 times 32. And it's going to be about 300. The distance from the dock is going to be about 332.8 meters. And I'll bet that looks about right. I mean, here's 325, here's 350, right? And it's just a little bit above the 325. So yeah, look at that. So that point of intersection is going to be 10.4 approximately, but that's good enough. 333, approximately 333 meters. We'll go with that. Okay, the point of intersection. All right, now what is happening in the real world at the time in part D? Oh, well, I mean, in the real world, that's going to be where the boat turns around. Don't you like my little drawing here? See how the boat's going, it's going away from the dock here, and then see how the little wind blows differently now. So I thought I was quite clever there. So at any rate, the boat is going to turn around at 333. That's supposed to be a 333. At 333 meters, it's going to turn around. When did they arrive back at the boat dock? Well, I mean, you can't see on mine, but they're going to arrive back at the boat dock whenever this line hits the x-axis, right? I can't see that, but it's when that line's going to hit the x-axis. It's actually going to be, so this is problem 28, right? 28F. It's actually going to be when g of t equals 0. So let's find when g of t equals 0. It's going to be 0. 0 is equal to negative 17t plus 510, right? So 17t equals 510. And so t is going to equal 510 divided by 17. Now, if I had done my scale a little better, I could have just seen this on the graph, and I wouldn't have had to maybe worked it out all the way. I still would have maybe, but all right. So you can see at t equals 30 minutes. If my graph had gone all the way out to 30 minutes, it would have intersected the x-axis at t, at x equals 30 minutes, or t, because remember, on the x-axis is time. So when time equals 30 minutes. All right, then the last part here. Assuming that they were going the same speed through the water for both parts of the trip, did they start out going upstream or downstream? And let's justify our answer. Ooh. Well, look at here. I mean, if this is the turnaround point and they went the same distance both ways, right? I mean, the boat went out 333 meters, then the boat turned around and it went back 333 meters, right? But look at how much time it takes. To get 333 meters, it takes 10 minutes going there. So do you see how that's going to be? So that's going to be the boat's going with the current, because that's a pretty quick time. I mean, my total time is 30 minutes, right? Total time's 30 minutes out. So it's going to take 20 minutes going back. So it's going to take 10 minutes going out, but the boat's going to turn around. It's going to take 20 minutes to come back. So it's going against the current coming back because it takes more time. The current is going to help it get there. So if it only takes 10 minutes to get out 333 meters and it takes 20 minutes to go back 333 meters, yeah, that's All right. Just for fun, see if you can figure out the speed of the current in the San Antonio River. Oh, just for fun. Shall we do that just for fun? Figure out the speed of the current in the San Antonio River. I'm not sure I can do that. Let's see. Distance equals rate times time, right? And let's see, we have the distance going there, which is 333 meters, has to be the distance, and we'll call that D1 here, I don't know. And let's see, coming back, the San Antonio River coming back, we'll call this D2. Oh boy, I'm not sure. Look at my time here already. I'm not sure. Let me stop my recording right now. So, and then let me, if you want to do the current, just do the next little video, okay?